This is Prince, and here is my quick demonstrations of my submitted applications for the hackathon. Now, for this particular hackathon, I have submitted a particular topic which is named as Intelligent Human Computer Interfaces. Now, essentially, we know that for world's 90% of population, we have desktop PCs and basically personal laptops where they are using Intel processors for their work. Now, imagine there is a scenario that if your personal computer can actually tell you some important things about yourself. So what if the computer can see your posture and maybe nudges you in correcting it? And what if it can see how close you are basically to your laptop screen, and it also creates a alert that okay, maybe just step back and take a much needed break. What if it can blur out the unnecessary part of your information which is basically getting shared in meetings, and it's basically a common thing which happened in after COVID work from home scenarios where we sit and share our screens. uh, uh, what if we can maybe also control our applications by simple gestures which you can do by hand, or which when you can also customize them according to our task. uh, Maybe it can organize your galleries according to a context, good context, right? So let's say if you have gone to a place and then you have clicked some photos, and let's say if it organizes that into a correct way, let's say somewhere near the lake, if all the photos are together, or for some certain faces it can group them together and tell you okay, this is for that person's, the gallery is basically telling you that particular feature. Now all these features sound very compute intensive, and essentially saying it's all possible in today's scenario where we have seen the advancements of artificial intelligence and computer vision. So using those particular algorithms we can actually solve these kind of problems. But here's the catch. So we cannot run them without specialized hardware. So in this case we are talking about GPUs. Now these certain amount of GPUs, what they do is basically run these deep learning models into a parallel fashion, and they compute on a particular set of images and let's say high intensive data, and they give you some features. Now what we can do is, let's say we can use certain toolkits which are being developed by Intel, and what we're talking about for this particular hackathon is usage of one API, right? So let's say we can compress them. We can compress those deep learning models which are accustomed to our task, right? And then we can run over a sequence of images. uh, let's say these particular tasks, right? So they require a wide range of settings where basically saying the Intel processors can be of various generations. Now maybe in this year it's basically 13th generation, but let's say for the previous 5 years there is generations of fifth generation, sixth generations. Now what if it can also take a look into that particular spectrum of processors and also run those features without any delay. So that's where the usage of one API comes in, where it handles all those kind of particular things. Now basically saying how scalable is this solution is, right? So let's say these applications which we are talking about can be intelligent, but essentially saying we are not requiring a backend hardware, which is basically saying we are not sending the data to the cloud. So in a way it's all taking up the computer's memory and RAM, and now we can also maybe cut down some features, or maybe make them accustomed to a particular processor, which we can say that okay, for this particular set of utilities and this set of users, so it can run nicely, right? So that's where the one API is also very much needed to increase the scalability of the solution. Now for this particular quick demonstrations, I have submitted like 4 deliverables right now. One of them is a document reader. Second one is how you can play Temple Run by your camera without your keyboard. Then there is a smart camera which actually dissects the image into person's images, where you can actually select a person for a certain area. And then there's a center stage. Now center stage is as an application where you open up your webcam, and it follows you inside that particular frame. So how we can develop these kind of applications using one API, where we have actually taken Openvino's code bases to utilize such kind of things. Now I will turn off my camera, and maybe I will go through the code. All right. So the first application is document reader, and what we are doing here is what we can basically see is so this whole code is getting committed into a repo, and this repo link is also getting submitted into the hackathon page. What we will do for this particular first demo is a document reader application. Now this is a desktop application. Now for this desktop application, I have implemented a text spotting deep learning model. Now this deep learning model is run only on the CPU, right? So it can actually run on any set of applications. So let's run this application. All right, so as we can see, the application is open, and let me maximize this application. So this is one application which is basically said as Intel Lens. What we will do here is let's say select a image. So I will pick out an image for this particular application to process, and I do have a test image for the demonstration. So let's say I have gone to a zoo, and I have gone there and taken a photo of this particular zoo. So I maybe want to know, okay, this is a image where I want to know for which set of place I have gone to, right? So I can actually see that, okay, the model has detected let's say the correct bounding boxes, and even let's say the contour of the whole text, where it is actually aligned in a circular fashion, right? So it's not getting let's say affected by the orientation of this particular text, where the model is actually able to read all the text which are basically read by human. So maybe we can use this particular feature for our document reading, and use this continuously, right? So now the next applications which I wanted to show you is a smart camera. So here let's say I will also run the same command. Now every project is getting a readme file for it itself. So every application you can actually see your readme file, and let's see for this particular demonstration how we can utilize the document. So from the document reading functionality, we can actually use a smart camera feature. So for this application I will choose an image which let's select my image right now, right? So as you can see, this is getting detected, but let's say if I find it out again. So yeah, so now I can actually select this whole mask and then put it somewhere into a document or somewhere where I can utilize this for a certain number of other features, right? So this is all done locally on the CPUs of my laptop. Now this laptop has an i7 processor, which which has 6 cores, right? So it's pretty fast for my use case, but it can be different. But let's say the Openvino toolkit can actually speed up on a certain number of core. So it's for a single image, it's fine, and we can utilize this multiple number of times. Now as you can see in the background, this is an application which is running, which is loading certain features of the input and the output, where the model is on F32, right? So this is all in the backend which is running. So if I package this application, it won't be showing all these logs. Now let's go to a quick good application right now. So here I have a center stage. So here also I can run the same command, and let's wait for the application to turn up. So now as you can see, it's tracking my face, right? So if I go here, it can also detect that change, and for a small meeting scenarios, it's basically going on the real-time detection. So it's tracking my face, and wherever I move it, it's basically dissecting all the unnecessary informations which is in my background. So all this information is gone, and this is the final output, which actually is an application by actually the Mac OS, which is called center stage. Now this center stage is now also getting let's say this application is very easy to develop. It's tracking just the face, and we can just say that okay, this is using Intel's APIs for that use case. um, the last application which I want to focus on is a gaming application actually, and this game actually everyone knows now. So it's a temple run game, and to run this project, right? So there's a, of course, as I said earlier, the readme files are there for every applications, so you can go there and check it out, and then even run those applications for your use case. Now here's the quick summary of this particular requirements file, where these applications require a certain environment to be there. So this requirement or text file contains something like it contains a series of libraries which I have used in Python. Now these series of libraries contains this Openvino tag, where we can package them together, and it's not like let's say when you package it, so these applications or these libraries would be going away. So once it is packaged into a flat application as a desktop application, this will package them together, right? So for our use case, the requirements file is actually covering the version perspective, where we can maintain this file, and for coming releases, let's say if we make small changes, we can actually change this file also. So let's see the temple run project, where I have opened the readme file of that. So it's a Flask web application. Now this particular thing is a separate, it's not a desktop application, but it's a web application where we demonstrate the game controls by running a camera and our let's say game. So let's run this. All right. All right. So we will wait for the camera to get up, and as you can see, it's actually tracking my face with my posture. So this posture is basically detecting my face, and as well as my the eye points and the nose points. So let's click on play. So depending on the so let's say the video recording is on, so that's why it is taking some amount of time. But let's say if you are playing it natively on your desktop, this will be faster. So we are using this open source implementation of our game, which is given by a certain library, which of course is acknowledged into the readme file. All right, so it's also playing the music of the temple run, and let's click on play button. Let's see what happens. So as you can see, we are running, and now it is saying to jump up, right? So let me go above. So now I can play this game. All right. So I got a score of 17, and as you can see, I have to move my face for running around. Right? So was not utilizing my keyboard controls. Now those controls are basically aligned towards my face detections. So yeah, this was the whole demo. And all right, so what is the future of these particular applications now? What I would say is, let's say these are some set of small applications which we have developed using this one API toolkit. Now what we can do is basically use more number of models, or maybe use let's say the higher advanced models for a certain range of CPUs, where we can actually test them across the whole area of processors. So yeah, this was a whole demo of this particular project, and thank you for listening.